Welcome to section 5.6, linear inequalities. Today's objective is to solve inequalities in two variables. So that's something to put in your notes. The solution of a linear inequality with two variables, we have x's and y's, is the half plane containing all the ordered pairs that make the inequality true. And that's the key, is when we do inequalities in two variables, we will graph them to find the solution sets, because there's multiple answers that work. And it's the half plane that contains all those ordered pairs. So to graph a linear inequality in two variables, we want to follow these steps. Put the equation in y equals mx plus b form if necessary. Quite often you're going to want to do this so you can see what the inequality looks like. Graph the boundary line. Use a dotted line for the less than or greater than sign, and use solid lines for less than equal to or greater than equal to. When we did it the other day with inequalities, we had open circles. When we didn't have bars, well, an open circle is a dotted line, basically. And then when we have the equal bars, we have a closed circle. And the same thing with a line, we have a closed line. That's why it's a line, a solid line, not a dotted line. For step 3, test a point not on the line. We check it whether or not that ordered pair is a solution of the inequality. So we're going to pick some point not on our line, we're going to test it in the inequality and see what we get. It will tell us if that point is or is not in the solution area. Then step 4, shade the side containing the point. If it is a solution. If it isn't a solution, shade the other side of the line. We're going to go through a few of these to see what this looks like. Here we have graph y is less than negative 1/2 x plus 4. Just by looking at this, we should know right away, if we have a less than symbol, that we are going to have a dotted line. We know that. And this is already in slope-intercept form. So we have an intercept of 4. We have a slope of negative 1/2, so down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. This is a dotted line. So I'm going to do this as best I can. So we have a dashed line. We still have arrows on the ends, but it's a dashed line. The next step, so that's our first step, was to put it in slope-intercept form, which it already was. Our second step was to graph the line, the boundary line. Our third step is to pick a point somewhere on the graph that is not on the line. And usually the best one to pick, if you can use it, is 0, 0. It's the easiest one to use. So we plug in 0 for y and 0 for x. So 0 less than negative 1/2 times 0 plus 4. Is 0 less than 4? It is, which means the point 0, 0 is in the solution area, which means we shade this side of our graph. And this is how we solve inequalities in two variables. The only way to do this is we have to graph them. So we graph the boundary line, we test a point not on the line. If it's in the solution area, we'll get a true statement, and we shade that side. If when we plug that point in, it does not have a true statement, it means that point is not in our solution area, and we shade the other side. So here we have 2y plus 4x is greater than 8. And again, we want to put this, since it's an inequality, we want to put this in slope-intercept form. To do that, we need to move the 4x. And we can usually graph these actually off of these intercepts, but we have to be careful with some of these because you may have problems with the inequality symbol itself, depending. So we have 2y is greater than negative 4x plus 8. Divide everything by 2. And we get y is greater than negative 2x plus 4. So we have, this is our line in slope-intercept form, our boundary line, so we're going to graph it. And this one has an intercept of 4. And we have a slope of negative 2, so down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And this again has a greater than single symbol, so we are just going to use a dotted line through. Make sure you put your arrows on the end still. We will do a test point. We will test 0, 0, And do let me know what you're using for a test point. So 0 is greater than -2 times 0 plus 4. Is 0 greater than 4? It is not. So 0, 0 is not in our shaded area. It is not a solution. So we have to shade up and to the right. And this is the graph, and the solution for 2y plus 4x is greater than 8. Next one we have is y is less than or equal to 2. So with y less than or equal to 2, this is a horizontal line, and y is less than or equal to 2, so that's our border. We have an equal bar in here, so this is my line. And if you can see that we're less than, you can just shade below, but you could put 0, 0 in here, and you'd find that 0 is 0 less than or equal to 2. It is, and we are shading below. And again, this is a horizontal line when you have y equal, or in this case, less than or equal to a number. And if it was x less than or equal to, it'd be a vertical line. The next step we do is write the inequality represented by the graph. So the first thing we need to do is write basically the equation of the line, but leave the equal sign out for now. And we'll leave a blank spot there for our inequality. When you look at this, you'll see our y-intercept is -2. That's our b. And we have a slope from there going down 1 over 3. So our m, our slope, is -1/3. We have our slope and our intercept. So I'm going to write the inequality for my line. I'm going to leave the equal sign out and leave the inequality symbol out for now. And we have -1/3 x minus 2. Now we want to figure out what inequality to put in here. And you'll notice that we have a solid line. So that means we have an equal bar. And we are below, all my y values are below the line. So we want a less than sign. If you want to test this to see if it works, we can do a test point to see if our inequality is pointing the right way. And for this, we want to put in a point that is in our shaded region to test. And I always pick easy ones. And if you look at an easy one, would be 0, -3. So does -3, is it less than or equal to -1/3 times 0 minus 2? Is -1/3 and -1/3 times 0 is 0. Is it less than -2? It is. This verifies that our inequality symbol is pointing in the right direction. And here is the inequality from this graph. But you can do a quick check to see if you wrote the inequality symbol correctly by putting in a point in the shaded region and making sure your inequality is true for that point. So here we have write the inequality represented by this graph. I would like you guys to try this by yourselves first and then see if you get the same thing I get. So here we have m, our slope, and our intercept. Our intercept is at -6 down here. And our slope from there is going up 2 over 1. So our m is 2. So we have y. We know it's 2x minus 6. We have a dotted line, which means we don't have an equal bar. And we are above, all my y values are above my line. So we want a greater than symbol. And to test it, if we want to make sure our inequality is correct, let's plug in a point, and I'm going to use 0, 0, because it's in our shaded region. So a 0 greater than 2 times 0 minus 6 is 0 greater than -6. It is, which shows that my inequality symbol is pointing correctly, and I have the right inequality symbol in there. And this is how you write an inequality off of a graph. That is all for section 5.6. Today we did inequalities and graphing, and we have 2 variables. Make sure you put these into slope-intercept form for when you graph, if they aren't already in there, to make sure you have the right inequality symbol. Thank you for watching, and have a nice day.